Okay, in this lesson we are going to look at rates of change in terms of business and economics. So things like cost, revenue, profit. So just keep in mind that the variable X is always representing the same thing. It's the number of units produced and sold. So how many items are we selling or producing? So some vocabulary at the beginning of the guide. Cost is the total cost of producing X number of units, so that is always represented by C of X. Revenue would be the money you make from the sale of X units, and so revenue will always be X, the number of units, times the price. So that's how you make money. And then profit is the difference between the revenue that you earn, take away the cost, and that will give you the profit. The price function or demand function is represented by P of X, so that's lowercase p, and it's the price at which X units can be sold. So as I said earlier, revenue is the number of units sold times the price. The break-even point would be where you're not making any money or losing any money, so that's where profit is 0 and cost equals revenue. So the amount of money you're spending is the same as the amount of money that you're bringing in. The marginal cost is the first derivative of cost, and it's the change in cost of producing one more unit. The marginal revenue is R prime, and that is the change in revenue of selling one more unit. And marginal profit is P prime, which is the change in profit from selling one more unit. Okay, there's a table here to be filled out. Let me see if I can make this a bit bigger. Okay, so just looking at summarizing what each item represents. So price function or demand function, that's lowercase. Let's do this in blue. So that's lowercase p, and that is the price each unit is sold for. Revenue we said was capital R, so R of X, and that is money coming in from selling. So it's from selling X units. So we said R is X times the price. Profit is capital P, and that is always going to be the revenue that you bring in. Subtract any cost to produce the item. If profit is positive, you are making money. And if it is negative, you are losing money. And then average cost is just your total cost divided by number of units that's sold. Okay, so that's just some vocabulary. The derivative, oops. So derivative is just R prime. Marginal revenue. Profit is just P prime. And what does that represent? It is the change in total revenue from selling one more unit. So from selling one more unit. And then P prime is the change in profit. From selling one more unit. So that's just a summary of all the terms that we're going to be using. So let's look at an example here. So here we have a manufacturer that can make and sell a certain number of units, X units, for a price P. So the price equation is given. It also gives you the cost equation. So A says determine the revenue function. So remember, revenue is going to be number of units times the price of those units. We were given the price equation as 600 minus 0.3x, so we'll just simplify that by expanding. So there's our revenue function. Determine the profit function. So remember, profit is going to be revenue brought in minus the cost to produce those items. So revenue we just found. And then we're going to subtract the cost equation, which we were given at the beginning. And if we just simplify this, we get negative 1.3x squared. Just collect like terms. 400x minus 8,000. So that's our profit function. And then it just wants us to use that profit function to find the profit on 200 organizers. So we're just going to do P of 200. We'll just substitute that into our profit equation. And we will determine profit of 200 items. That works out to be $20,000. Okay, D says calculate the marginal profit on the sale. So now we want to find P prime because we want the marginal profit. So P prime is going to be minus 2.6x plus 400, and then we want to find that marginal profit at 200. So it's pretty straightforward. You're just using the proper equation to determine what's being asked. So the marginal profit of 200 items is a loss of minus 120 per organizer. E says calculate the marginal cost. So we need to find, I wrote an M. We need to find our marginal cost equation. So we'll find the derivative of cost. So that'll be 200 plus 2x, and then we want to find that at 200 organizers. So the marginal cost is 600 per organizer at 200 items. And let's see, calculate the marginal cost when 200 are produced and the price each can be sold for. So the price is just the price equation at 200. So the price equation was 600 minus 0.3x. So it's going to be 600 minus 0.3 times 200 organizers, and that works out to be $540 each. So we just use the price function for that. And then F says calculate the maximum profit and the sales needed to realize this profit. So maximum profit would be our derivative of profit, right? Because we want the maximum. So that equation is negative 2.6x plus 400, and we want to solve when it's maximum. So that would be equal to 0, and we'll solve for x. And so x will be 150 organizers to make a maximum profit. Which makes sense because when we found at 200 organizers, we saw that we were having a negative profit. So we want to have a maximum profit, and then the price or the profit would be 154 into the profit equation. And that would give me a maximum profit of just a bit more than 22,000. Okay, so those pretty basic questions. You're just following through and determining which equation to use. Okay, in 14, we are given a price function, and we're given a cost function. So we want to find the break-even point. So remember, the break-even point, cost equals revenue. And so what we need to do first is find that revenue function because we're not given that. So revenue is number of items times the price. and the price was given. And so once we know that, then we want the cost function, which is 3,000 plus 19x squared, equal to the revenue function that we just found. And so since we want to solve, let's set it equal to 0. So we'll get everything on one side. So we'll bring this over to the left. And I'm going to use a quadratic function to solve this. Because I don't think we can factor it. So plug all those numbers in. And x works out to be 46.8 or 3.2. So the question says the break-even point. So the break-even point would be either selling 46.8 items or 3.2 items. Because remember, you're going to have some sort of quadratic function here. Don't need that there. Okay, so now we want the price that will maximize profits. So our profit equation is revenue minus cost. So we need to figure out how many items we would need to maximize our profit. So first we need a profit equation. So let's find that. So we've got the revenue equation. Subtract the cost equation to give us a profit function. So that works out to be minus 20x squared plus 1000x minus 3000. And then we want the maximum profit. So we'll find the derivative and then set it equal to 0 and solve. And so x will be 1000 divided by 40, which is 25. So we would need 25 items to break even, or sorry, for profit, for maximum profit. And so that price would be 1000 minus 25, which is $975. And then finally, it says what is the maximum profit? And so the maximum profit would be at when x is 25. So we want P of 25. So we'll just sub this in here into our profit equation. And it works out to be $9,500. So that is our maximum profit when x is 25. Okay, finally, let's look at this one. So these are all taken from the guide, right? It's just some practice questions. So this one says EastJet flies an airliner, 190 passengers. The ticket price is given at $320 minus X. What price should be advertised to maximize revenue? And then at this price, what percent of seats will be empty? So we want to maximize revenue, so we need a revenue function. So revenue is number of items times the price. And the price is given as 320 minus x. So our revenue function is minus x squared plus 320x. And then we want to maximize revenue. So we'll need our prime. And then we're going to set that equal to 0 to find the maximum. So x will be $160. Okay, so that's the price that we should Sell to maximize revenue. Part B says at this price, what percent of seats would be empty. So we need to figure out at this price what number of seats would be sold. So I'm going to use my maximum revenue function. I'm going to put in that price and solve for X. Oops. I think I'm missing an X here. Okay, I made a mistake here. We're supposed to be putting this into price because 160 was the price. So wrong function. Let's erase all this. So our price, oops. Our price was 320 minus X. So we're putting it in the price function. And so X will be 160 seats. So we would need to sell 160 seats to maximize revenue. And so it wants to know what percent of the seats will be empty. So if we sold 160 seats out of 190, that would be 0.84 or 84% full, which means it would be 16% empty. Okay, so most of these functions and examples are pretty straightforward. You've got your cost equation, your revenue function, you've got your profit is revenue minus cost, and then you've got your marginal cost, marginal revenue, marginal profit. So pretty straightforward. Summarized in the table, all the formulas that you're going to use for this unit.